Greetings. Today's class will see classification of embedded system. So you have main two classification. One is based on the performance. So based on the performance, it is divided into small scale embedded system. What is small scale? It uses small amount of bits, that is 8 bits and 16-bit microcontrollers, and you will have very simple application. So we all know it's of low cost and low power consumption, and the examples are most TV remote and calculators. All these are small scale embedded system. The medium scale embedded system is the second classification under the performance. This makes use of 16-bit or 32-bit processors or microcontrollers, and it has a moderate complexity, and again uses a real-time operating system. In the case that you will be changing the task and it will be working accordingly. So examples are washing machines and printer. Third classification is sophisticated or large-scale embedded system, which makes use of 32-bit or 64-bit processor, and the performance is also very high and the functionality is very complex. It can support multitasking as well as networking. Examples of large-scale embedded systems are aircraft control system and medical imaging systems devices. You can see here it should be little complex here. So you call that as a large-scale embedded systems. And based on the application, you have another classification based on application. Based on application, it is said to be as standalone embedded systems. Standalone embedded systems are very simple embedded systems where it can get some inputs, produce a output, and you need not worry about anything. It works as such. So it is again, remember, this is again this application, the devices can come under the performance also, but main classification is mainly based on the performance and applications. So this, it can operate independently without any dependence. So some examples are digital camera, MP3 players and microwave ovens. All will come under the standalone embedded systems. And the next category is a real-time embedded system, where it produces an outputs within a specified time limit. So this needs an RTOS, and remember you have another two kinds classification under this. One is said to be as a hard real time, another one is a soft real time. Hard real time is based on a deadline, this has to work, and again missing a deadline can cause a system failure or again a catastrophic. It means, for example, you can consider an airbag control system. So this should work based on a accident or based on a vibration. If it does not work, that may lead into a catastrophic condition. That is said to be as a hard real time. It has to meet the deadline. Whereas in the case of a soft real time, missing a deadline does not causes a system failure, does not causes a catastrophic. And something called as a multimedia system, where you have many applications or many video and audio applications running, and if it does not run, it does not produce any kind of a system failure, it does not produces a catastrophic condition. That is called as a soft real time. And the next embedded system classification is networked embedded system classification. And we all know, and again nowadays we live in that era where all the systems are connected through the network, or wired networks or otherwise wireless networks. Smart home devices, network printers, IoT devices all come under the network embedded system. So this is again, you can understand all applications what you live today, it's again connected to the internet or networked either through wired or wireless. You can see to the diagram all these smart home devices where it's useful for the IoT or smart home. And the next one is a mobile embedded system. This embedded systems, it makes use of portable, and it will be a portable and battery powered, and again this is also a networked, and you can see here smartphones will come under the mobile embedded system. The fitness trackers, the digital camera, again we already saw this in a classification as an example in the classification, and smartphone, fitness trackers, digital camera, all will come under the mobile embedded systems. This is a comparison what is given. You have some classifications as small scale, medium scale, large scale, standalone, real time, networked and mobile. So this is mainly based on the application and based on the performance and functionality. And a description is given. For a small scale it is simple and low cost, and medium scale it's moderate complexity, and large scale it's high complexity, complex systems. And we know that the small scale will make use of 8-bit or 16-bit, medium scale is 1632, and large scale is 32 or 64 bits. And again, for the standalone, it works independently. Real time, it's mainly based on the time constraint or time critical operation. Networked is connected to a network, and a mobile is portable embedded devices. And some examples are also given. Thank you.